We're surrounded by the largest, most complex engineered system that humanity has ever built. We use it literally every second of every day. But how many of us really get how it all works? So today, we're going to pull back the curtain and take a look at the incredible architecture of the internet.
To really wrap our heads around the scale we're dealing with, just look at this number, 40 exabytes. That's the estimated amount of data that's flying across the internet every single month. It's just this constant, unbelievable flow of information that connects the entire planet.
So that's the big question, right? How does this massive, kind of chaotic-looking thing actually function? What are the key pieces and the essential rules of the road that let billions and billions of devices talk to each other so seamlessly?
Okay, so our journey is going to start at the part of the internet we all know best, the network edge. This is where every single piece of data starts its journey or finishes it, right here, with the devices in our hands, on our desks, all around us.
Now, in network speak, these devices are called end systems, or sometimes hosts. Just think of them as the starting points and the final destinations for absolutely everything that travels across the internet. So when you send a text, your phone is one end system, and the server that gets it is another. Simple as that.
And wow, the sheer variety of these end systems has just exploded. I mean, it's not just about computers and servers anymore. Now we've got our game consoles, our smart TVs, webcams, you name it, even tiny little sensors. This is really the foundation of what we call the Internet of Things, this world where pretty much every object has a digital pulse.
Okay, so we've got our start and end points, but how does a message get from your phone in, say, New York to a server in Tokyo? Well, for that, we have to go beyond the edge and dive into the network core, this huge system of digital highways and intersections that connects everything together.
Here's a super important point. The internet doesn't just send your email or that video you're watching in one giant chunk. Nope. Instead, it chops it all up into these small, easy-to-manage pieces called packets. It's kind of like shipping cargo in a whole bunch of smaller trucks instead of trying to move the entire warehouse at once.
And these little packets don't just fly straight to their destination. They actually hop between these specialized computers called routers. And these routers use a method called store and forward. So a router has to receive the entire packet before it can even think about sending it to the next stop. It's just like a truck pulling into an intersection. It has to wait until the road ahead is clear before it can move on.
So, we've been throwing around this term digital highways, but what are these roads actually made of? Let's take a look at the physical stuff that carries all this data all over the world. Well, it really boils down to two main types of pathways. First, you've got guided media. That's where the signals are physically contained inside something, like a fiber optic cable. And then you have unguided media, where signals just travel freely through the air, like the Wi-Fi signal you're probably using right now. And look, these are things you use every single day. The guided stuff includes the old copper wires for DSL, the coaxial cables for your TV, and of course the incredible fiber optic lines that form the super fast backbone of the internet. And on the unguided side, you've got things we all know, like Wi-Fi and satellite connections.
All right, so we've got the devices, the data packets, and the physical roads. But without any rules, it would just be complete chaos, right? That's where protocols come in. You can think of protocols as the Universal Rulebook of the internet. They're like a shared language that makes sure every device can understand every other device.
The easiest way to think about a protocol is like a super strict agreement. It defines the exact format for a message, the precise order of the conversation, and the specific actions that need to happen when a message is sent or received. It's basically the grammar for all network communication.
Just think about a simple human protocol, like asking someone for the time. You say hi, they say hi back, you ask your question, and they respond. It's a set sequence. Well, a computer asking for a web page follows a really similar protocol, just at the speed of light. It sends a connection request, gets a reply, asks for the data it wants, and then gets the file back. It's the same idea.
Okay, so there are literally thousands of these protocols out there for all sorts of specific jobs. But the two absolute rock stars, the ones that form the foundation of pretty much everything we do online, are TCP and IP. That's the Transmission Control Protocol and the Internet Protocol. Together, they are the bedrock of our digital world. All right, we've talked about devices, packets, and protocols. But listen, if there is one single thing you take away from all this, it has to be this next idea. This is, without a doubt, the most important insight for really, truly understanding what the internet is. So here's the biggest misconception about the internet, that it's just one giant, single network, maybe controlled by one company or one government. That is just not true. The reality is so much more interesting and honestly a lot more resilient. The truth is, the internet is a network of networks. It's this huge, sprawling web made up of thousands of individual networks. All of these networks are run by different groups called Internet Service Providers, or ISPs, and they've all agreed to connect to each other. This decentralized design is the internet's greatest strength. It's what makes it so robust.
Think about it. The company that gives you Wi-Fi at home, or your university's campus network, or your cell phone provider, yep, those are all ISPs. Each one is its own independent piece of this massive puzzle. And it's only when they all connect together that they form the single global system that we call the internet.
So there you have it, from the devices in our hands through a core of routers and physical cables, all governed by a set of rules and all built on this incredible network of networks. The whole system is just amazing, but it's always, always changing, which really leaves us with one final big question. As this Internet of Things starts to connect everything from our cars to our cities and even our own bodies, what comes next? What new challenges and what incredible new possibilities are waiting just over the